Okay, so in this video, we're going to be solving the remaining part of the paper that we did in the last class, which is May, June 2001, paper 1, variant 2. You might have noticed that I've skipped question number 15 very conveniently. Now, the reason behind doing that is that to solve a question like this, you need a proper ruler and compass, and I'll make a separate video on this where I'll solve this question and a couple of more questions similar to these, and just sort of compile them in one single video and solve them for you guys. But for now, we're skipping it and we're coming straight to question number 16. So it's a question that belongs to the topic of indices, and you're asked to find the value of k. So if I were to simplify this, so the k and the minus 2 get multiplied, because when you have a power which is raised to another power, that's what you do with the powers, they get multiplied, which is equal to y raised to the power 5. So what we do is we don't cancel the bases, we kind of ignore the bases and just compare the powers. So minus 2k equals to 5, which means k is equals to minus 5 over 2. The negative sign is always written with the numerator because it just looks nicer that way. Okay, then we have part B, where you're asked to simplify. So if you have x to the power 1 upon 3, which you have to cube, so what you will have to do is you'll just have to multiply the powers, just like we did in the first one. So that's going to be x to the power 3 upon 3. But this cube applies to whatever you have in the denominator also. So that means you're going to cube 2 along with x. So 2 cubed is 8 and x cubed is x cubed. So what you're looking at is x upon 8x cubed. Why x? Because 3 upon 3 is 1, so x to the power 1 over 8x cubed. So then what you can do is you can shift this x, not shift, but like sort of reduce the cube from x in the denominator by 1 by basically getting rid of the x power 1 in the numerator. So long story short, what I'm basically doing is 8x to the power 3 minus 1, or you could have just let the 8 be as it is and have x to the power 3 be simplified with x to the power 1 in the numerator. So either way, your answer would either be x to the power minus 2 upon 8, or if you were to solve this further, your answer would be 1 upon 8x squared. I would personally prefer 1 upon 8x squared because it just looks nicer that way, you know, rather than having x to the power minus 2 upon 8. But anyway, that's me. You can write it whatever you want, both are acceptable. Question number 17, it says, in a sale, the price of a coat is reduced. So I'd underline the word reduced by 25%. The sale price is $120. Calculate the price of the coat before the sale. So that means this $120 that you're looking at is the reduced price. So if you've been following, you know that I have a standard way of solving questions like these. So first, I like to make a column for percentage where I write the percentage. So $120 that you're looking at is basically equal to 75%. And if you're wondering why that is, because if you're reducing something by 25%, that means you're basically left with 75% of it, which is equal to 120. And if you want the original price, that's 100, which is equal to x. Now you cross multiply. Oh, I was about to pick up my calculator, but this is paper 1, so no calculator, folks. So nothing to worry about, should be easy. So 75 and 100, which you can simplify using the table of 25. So 25 3s are and 25 4s are, and then 3 1s are, 3 4s are 12, 0. So what you're looking at is 40 times 4, which is $160. And there you go, that's your final answer. Easy does it. Then it says y is inversely proportional to the cube of x. This is question number 18, by the way, variation. Find the formula for y in terms of x. Okay, so y is inversely proportional to the cube of x means y inversely proportional to 1 upon x cube, and then you write this nicely where you write k and x cube in the denominator, just like we did previously. Then you need a set of values for x and y to find out the value of k. So we have 24, which is equal to k upon 1 upon 2 cubed. So 1 upon 2 cubed is 1 upon 8, which if you multiply by 24, so you get k is equals to 24 times 1 upon 8, which means k is equals to 3. And there you go. That's not your final answer though. You still need to write it, you still need to write it nicely, replace k with 3. So you're looking at 3 upon x cubed as your final answer. Then it says find the value of y when x is 3. So this shouldn't be too difficult. So we have 3 as it is, and then 1 over 3, the whole thing cubed. So we're looking at y is equals to 3 over 1 upon 27, which basically means 3 divided by 1 upon 27, which basically means 3 multiplied by 27, which basically means 81, is it? Yeah, 81 is it. Yep, that's the correct answer. Okay. So we have question number 19 now. It says on Monday, 40 adults, 20 children visit a museum. On Tuesday, 30 adults and 35 children visit the museum. The cost of an adult ticket is $2.50, and the cost of a child ticket is $2. Okay. This information can be represented by the matrices M and N, and the question has done that. So this column is for, so basically over here what you're looking at is Monday. So row wise we have the days, Monday and Tuesday, and column wise we have the category, you can say adults and children. Okay, then it says work out MN, so we can do that. That basically means multiplying the two matrices and giving the final answer. So whenever you're multiplying matrices, I have a detailed playlist on matrices. Look for it and have a look at it. So what we do is we're doing row times column. So 40 times 2.5 is 80. 80 and half of 40, so that's 100. 100 plus 20 times 2 is 40, so that's 100 plus 40. And then we do 30 times 2.5, which is 60, 75. Plus 35 times 2, so that's 70. So what you're looking at is 140 plus 145. Let me check if that's the correct answer. There you go. So while we work this out, it's very likely, yeah. So the question will ask you what it represents. Okay, like what exactly are you trying to find over here? I mean, we already said what exactly have you found over here. Then it says explain, and so it says explain what the numbers in your answer to part A, part 1 represent. So what they represent is basically the total revenue on Monday and the total revenue on Tuesday. Why so? What you've done is you've multiplied the quantity of people attending the museum or visiting the museum, on Monday by the respective ticket prices, and you've done so for Tuesday. So what you have, 140 is basically for Monday and 145 is basically for Tuesday. So I'll write total revenue earned on Monday and Tuesday respectively. Okay, so I'll just write out ESP. Whoopsie, sorry about that. Yeah, okay. Then it says the museum increases the cost of the tickets by 10%. Complete the new matrix to show the new ticket. Complete matrix P to show the new ticket cost. Okay, so you just need to show the costs. Okay, now if you're increasing the price by 10%, so that means now it's up to 110% of the original. Okay. Why? Because you have the original 100% and then you have 10% more of it. Okay, so what you're doing is so complete matrix P. Okay, so which one is matrix P? Wait, okay, so we're gonna call it matrix P. Okay, so originally the cost of the tickets were 2.5 and 2. Okay, so if you're increasing them by 10%, so that means you'll do 2.5 multiplied by 110 upon 100, because that's, like I said, that's how you increase anything by 10%. Okay, so for this, do we have to use a calculator? Yeah, we'll have to. Oh, maybe not. 2.5 times 110. Okay, so that's going to be 25. So that's 275. Okay, you can always work this out. You can take 25 multiplied by 110 and then just play around with the decimal over 100. So 275 over 100 is basically 2.75. There you go. And then we're going to do the exact same thing with 2, which should be a whole lot easier. 2 multiplied by 110 over 100. So that means you're looking at 200 and, let me see, 20 over 100, which is basically equal to 2.2. So that means the new matrix P looks like 2.75 and 2.20. Okay, since money is always written correct to 2 decimal places, because you got to show the cents also. So there you go, that's the answer to part B, which is correct. Okay, number sequences, one of my favorite topics. It says here are the first 4 terms of a sequence. Find an expression for the nth term of the sequence. This is a 4-mark question. Okay then. Okay, so how do we do that? Let's see. So here's the first term, here's the second term, here's the third term, here's the fourth term. So what I'm going to do is I'm just going to focus on the numerators for now, and we'll talk about the denominators later. Okay, so and then what we're trying to find out is basically the nth term, okay, for the numerator and the denominator. So 12, 17, 22 and 27. Okay, so this is an arithmetic series or an arithmetic an arithmetic sequence, because every preceding term is just 5 more and consistently 5 more than the previous term. Okay, so that means, like you can see here, that we're consistently adding 5. Okay, so if you remember, if you've seen one of my videos, you'll know that the formula for calculating the nth term of an arithmetic sequence is basically Tn plus a n minus 1 times t, where a is the first term, which we can see is 5, n will remain n because that's what it's for, and common difference is 5, as I mentioned earlier. So that means we're looking at 12 plus 5n minus 5, which means that we're looking at 12 minus 5 is 8, is it? No, it's 7, sorry. 7 plus 5n. So as far as the numerator goes, we know it's 7 plus 5n, okay. But now let's talk about the denominator, which I'm highlighting in blue, just so that I can distinguish. So we're looking at 16, 25, 36, 49. While you may not be instantly able to figure out the nth term of the sequence, but one thing that you should instantly be able to figure out is the fact that all these terms are perfect squares, okay. So the first term, the second term, the third term, and the fourth term are basically perfect squares. So while the first term is square root of 4, okay, the second term is square root of 5, the third term is square root of 6, and the fourth term is square root of 7, okay. While you can use the formula of a quadratic sequence over here, it's going to work wonderfully. I mean, it's going to wonderfully, if that's a word, okay. But I would rather avoid that, because there's a hack, you can say. Not exactly a hack. I mean, you just need to be able to pick up that pattern. So for the first term, what you're doing is you're basically squaring 4, okay? And for the second term, you're basically squaring 5. For the third term, you're basically squaring 6. So the term that you're squaring is always 3 greater than the term that you're at, okay? So if you're at 1, you're squaring 4 because it's 3, and 4 is 3 greater. At 2, you're squaring 5, which is 3 greater than 2. At 3, you're squaring 6, which is again 3 greater than 3. At 4, you're squaring 7, which is again 3 greater than 4. So that means when you're at n, so what you're going to be doing is you're going to be squaring a value that's 3 greater than n. That means n plus 3, the whole thing squared. Okay. So that means now we have the numerator sorted out and the denominator. So the numerator is 7 plus 5n, and the denominator is n plus 3, the whole thing squared. And there you go. That's your final answer. Okay, now we're at question number 21. Completing square, again, very important, something that has just recently started appearing in past papers, so something you should always pay close attention to and not skip it. So it's very simple. Again, I have a video on it. You guys are very welcome to check it out. I mentioned quite a few videos along this video. I hope I remember to attach all of them. If I don't, feel free to ask me in the comment section below. Okay, so here you have x squared plus 10x. And then I'm going to leave some space and write 6, okay. So to complete the square, what we do is we look at the coefficient of x, which is 10, and then we add half. We half it and then we square it. So that means we're going to add 5 squared, and then we're going to add 5 squared over here also. Sorry, we're going to subtract 5 squared here just to maintain balance. So because this is an expression, so if you're adding something, you got to make sure you subtract it to maintain balance. Had this been an equation and we had added something on the left hand side, we would have added the exact same thing on the right hand side also. So this sort of compresses into x plus 5, the whole thing squared, and 6 minus 5 squared is 6 minus 25, which is equal to what? 6 minus 25 is 19, is it? Yeah, so 19 it is. And there you go, that is the correct answer. So we'll write it over here, x plus 5, the whole thing squared, minus 19. Again, I'd strongly suggest to check out the video that I've made. I've done a beautiful derivation of it. I mean, I'm not trying to take the credit for it. I'm just saying that this whole concept is quite beautiful. Okay, then it says use your answer to part A to solve x squared plus 10x plus 6. Give your answer in the form p plus minus under root q equals to 0. Okay, so what we have done is we've basically rewritten this as x plus 5, the whole thing squared, minus 19 equals to 0, which means if I want to solve this, so this will be x plus 5, the whole thing squared equals to 19. And to solve this further, we'll take the square root on both sides, which means x plus 5 is equal to square root of 19 with a plus minus. And then if I make x the subject, so that means square root of 19 minus 5 with a plus minus over here. Why plus minus? Because whenever you're taking a square root of a positive number, you have a plus and a minus answer. And then since the question says that you're supposed to write your answer in the form of p plus minus under root q, so no worries, nothing to worry about. We'll just write minus 5 first and plus minus square root of 19 after. There you go. Okay, so some algebra questions that we're looking at. Express as a single fraction in its simplest form. Again, not very difficult. So what you got to do is you got to take out the LCM. So you can take the LCM by simply multiplying the two expressions. 3 will be multiplied by x plus 5. So 3 times x plus 5. We'll simplify it in the next step. And 2 will be multiplied by x minus 7 again, which will simplify in the next step. Now as far as the denominator goes, it's up to you whether you want to expand it or not. Okay, I'll leave it as it is. Why expand it? Why do unnecessary work? Plus 2x minus 14. Got to be very careful of the signs though. So x minus 7, x plus 5 as it is. Okay, 3x plus 2x is 5x. 15 minus 14 is plus 1 over x minus 7 over x plus 5. Oh, x minus 7 times x plus 5. So I'll write it over here. 5x plus 1 over x minus 7 times x plus 5, and there you go. That's the final and the correct answer. Yeah, great. Transformation. Okay, another one of my favorite topics. It says describe fully the single transformation that maps triangle A onto triangle B. Okay, so I need to have a closer look before we can do that. Is it rotation? Let's see. How do you test? So basically, I'll tell you what the stage at which I'm at. So I need to narrow it down between rotation or reflection, and the best way to do it is to join all the corresponding points and see if there comes a point where they meet. So yes, there comes a point where they meet, so that means it can't be reflection, it has to be rotation. Okay, so now that I have sort of concluded that this is rotation, I need to write down what? I need to write down the, number one, I need to write down what the center is, I need to write down what the angle is, and what I need to write down what the direction is. Okay, so here's number one, rotation. So A onto B, so that means B is the image. So this is how it's moving, so that means this has to be clockwise and it's 90 degrees. How do I know it's 90 degrees? Because the line that was horizontal is now vertical and the line that was vertical is now horizontal. So I'll say 90 degrees clockwise, yeah, clockwise. Now what I need to do is I need to find the center of rotation. Again, I have a video on it, so I'd suggest you watch that. If you're, and normally what you do is you draw a perpendicular bisector, but there's a way through which you can make a perpendicular bisector without having to worry too much about the without having to worry too much about without having to use a compass and a scale. Okay, so these are the 2 points. So the first thing I'm going to do is I'm going to identify their midpoint. So here's the midpoint, and then I will take any one of the 2 points and rotate them either 90 degree clockwise or anti-clockwise. So let's say I take this point. So this point is 2 units to the right and 1 up. That means I'm going to rotate this 90 degree anti-clockwise or clockwise, doesn't matter. You just want 2 points other than the midpoint. You just want one more point other than the midpoint so that you can make a straight line out of it. So here is one perpendicular bisector. Okay, so I'm going to erase everything else. All right. Now it may sound like I'm rushing through what I'm saying. Okay, and I don't blame. I mean, that's how it is because I have a detailed video on it, and I'd strongly suggest you guys to check that out. And then I'm going to do the same for these 2 points. Okay, first thing I'm going to do is I'm going to identify what their midpoint is. So this is their midpoint. I will take any one of the 2 points and rotate that point either 90 degree clockwise or anti-clockwise. So let's say I take this one. So this point is 1, 2, 3 to the left and 2 down. So if I rotate this 90 degree, let's say anti-clockwise, so that's 3 down and 2 to the left. There you go. This is where it's at. That means what I need to do now is I need to join them with the help of a straight line. And you'll notice these 2 points are intersecting. They're intersecting at, let me highlight it for you over here, which means that the center is 1 and minus 1. So 90 degree clockwise, center 1, minus 1. Okay, let's check the answer to make sure that we're on the right track. So, yep, we're on the right track. Rotation 90 degree clockwise. 1 comma minus 1 is the center. Great. Okay, then it says transformation P is represented by this matrix. Okay, P maps A onto triangle C. On the grid, draw triangle C. So whenever you have a matrix that looks like this, K 0 0 K, it's basically enlargement, all right, with K as your scale factor. Okay, K being your scale factor. So that means over here the scale factor is minus half, and also the center is origin. So scale factor half basically means that your image is going to be smaller, okay, it will diminish, and minus means that it's going to be 180 degrees rotated, okay, and center is going to be the origin. So whenever the center is origin, and if you have to enlarge a triangle where the center is origin, all you got to do is you look at the scale factor and you multiply all your coordinates by the scale factor. So that's exactly what I intend to do. So we're talking about triangle, sorry about that, we're talking about triangle A here. So the point that I'm highlighting in blue has coordinates minus 2, 0, and if I multiply minus 2 and 0 by minus half, so I'll try and do it on the side here so that you guys can see exactly what I'm doing. Minus 2 comma 0, if I multiply them by minus half, okay, I get positive 1 and 0. So 1 and 0, there you go. I'm color coding it as I go along. And then let's highlight this point by green, which has coordinates minus 4, 0. So I'll write minus 4, 0, and then if I multiply this by minus half, so I should get positive 2 comma 0. So that means this is where I'm at. And then red. Yeah, let's use red. This point over here has coordinates -2 and -4, which means if I multiply -2 -4 by -half, I should get +1, 2. Yeah, so +1, 2 means somewhere over here. So now that I have everything sorted out, I'm just going to make a nice and smooth triangle. So I've used the color blue to make the final triangle, and there you go. This, wait a minute, there's something wrong. 1 0, 2 0, and 1 2. Yep, that's what I was wondering. There's something wrong over here. 1 2 has to be somewhere over here. In fact, exactly over here. And now I'm going to join these 3 points to make a nice and smooth triangle out of it. And we're going to label this one C, just like the question wanted us to. And there you go. That let's check the answer. 2 0 1 0 1 2. Yep, we're on the right track. Okay, so now we're doing question number 24, which belongs to the topic of statistics. It says a group of office workers are each asked to record the distance d kilometers they travel to work. The results for some of their journeys are shown in the histogram. Okay, so 20 workers who are in the 0 to 5 group, so that means the frequency of this is 20. So the question really didn't need to tell us what the frequency was, because if you have frequency density on a histogram, you can work out frequency by simply multiplying the frequency density by the class width, which is basically the difference in the two values on the horizontal axis. Okay, so 4 times 5 equals to 20, but the question told us, so thank you for that. Then it says there are 12 workers in the 20 to 40 group. So the question has made a big jump, and it's talking straight away about the 20 to 40 group, which is not drawn. So we have to complete the histogram. So that means first we'll have to calculate the frequency density, which, remember folks, is frequency upon class width. So frequency is 12, the class width is 20. So 12 upon 20 is 6 upon 10. Oh, let me write that nicely, which is 0.6. So that means for the next bar that we're going to draw, the height is going to be 0.6, which means it's going to move 3 boxes up. So there you go, this is 0.6. Okay, great. Then it says calculate the percentage of workers who traveled more than 20 kilometers to work. So the number of people who travel more than 20 kilometers are 12, okay? But that's not enough. You need to know what the total frequency is. That means I need to find out the frequency of every individual class width. So if I want the frequency for this, I'll do the class width, which is 1.8, sorry, not 18, but 1.8, multiplied by the class width, which is 10, so that's 18. So we have 18 people over here. And then if I want the frequency of this, so I'm going to have to do 6 multiplied by 5, so that's 30. In case you're wondering why 5, so the difference between 5 and 10 is 5, therefore 30 here, and 20 here. So 20 plus 30 is 50, 50 plus 18 is 78, 78 plus 12 is 90, so that means the total frequency is 90, multiplied by, wait, is it 90 or is it 80? Hang on, 50, 68, yeah, it's 80, sorry, my bad. So 12 upon 80, multiplied by 100, since we want percentage. Let's simplify this. So 0 and 0 cancel. 12 and 8 we can simplify using the table of 4. 4 3s are, 4 2s are. 3 times 2 is 30. 30 upon 2 is 15. So we have 15% of people who traveled more than 20 kilometers to work. Okay. This question is although from algebra, but questions like these I have barely seen a question that involves the concept of comparing. And yes, although we have been using the concept of comparing without realizing in indices, but I've barely seen a question like this. So they've tested, in fact I haven't seen a question that's like this. So they've tested a very rare concept over here, but anyway, not too difficult given that you know how to apply the concept that's tested over here. So it says here the algebraic fraction can be simplified to this. So now what exactly does simplify or simplification means? Okay, so there's a difference between simplify and solve. So if I have, let's say, x plus 3 over x plus 1, again not the answer to this question, but I'm just trying to explain a concept over here, over x plus 1 times x plus 2. So if I cancel out x plus 1 and x plus 2, so what I get is x plus 3 times x plus 2. So that means this is the simplified version. No need to put bracket here. So this is the simplified version. It's not the solution, because when you solve something you end up with a value. This is not a solution, this is just a simplified version. And if you want to go back, you can just multiply both sides by x plus 1, because that's what you got rid of initially, and you'll be back to the original version. Okay, so that's that. Now, if I look at this fraction, while I can't really factorize the numerator because I don't know what a is equal to, I can factorize the denominator by using a certain identity, which is a square minus b square, and a over here is equal to x, and b over here is equal to 4. And x square minus 4 square can be written as x plus 4 times x minus 4. So we have the numerator as it is, 2x squared minus 5x plus a over x plus 4 times x minus 4. Now what must have happened was that you would have simplified the numerator with the denominator and ended up with 2x plus b over x plus 4. Now this is not the solution, that means you can't really cross multiply and solve this, okay? But this is the simplified version, okay? Now if I want to bring the right hand side equal to the original version, that means I'll have to multiply both sides by x minus 4, okay? Now if I look at the two denominators here, it's really not going to help me find the value of x, find the value of a or b, because none of them have a or b. But if I look at the numerator and compare the two, notice how I'm using the word compare. You'll understand what that means. Oops, I've solved this before. Let me raise the answer. Yeah, so I'll show you what that means. So 2x squared minus 5x plus a is basically equal to 2x times x. So that's 2x squared minus 8x plus bx minus 4b. Okay. Now comparing basically works. What you do is you compare the coefficients. Okay. Now I'll tell you what I mean by that. So if you have 2x squared and then you have minus 8x plus bx, if I just want to scrape off the coefficient of x from here, so what I'll do is, first thing I'll write it nicely. Okay. So writing the positive number first, and then I'll take x common. So I have b minus 8 and then minus 4b, and then I will compare it with the left hand side. So what I'm talking about is that what's the coefficient of x squared? In fact, let's start with x squared. The coefficient of x squared on the right hand side is 2, and so it is on the left hand side, so really not going to help me. The coefficient of x on the right hand side is b minus 8, and on the left hand side is minus 5. So that means minus 5 equals to b minus 8, which I can now use to find the value of b, and b is equals to positive 3, and I have the value of b. And then what I'll do is I'll compare the constant. So the constant on the right hand side, constant by the way is any term that has no variable with it. So constant on the right hand side is 4b, minus 4b, and the constant on the left hand side is a. So now that I have the value of b, I can simply plug it in and work out what a is equals to. So a is equals to minus 12, and there you go, we have the value of a, which is minus 12. Anyway, so that brings me to the end of this question, thankfully, end of this question and the end of this paper, and also the end of this video. I hope you guys have understood all the concepts that I've covered over here, and that's all. I'll see you guys in the next video. Until then, take care. Bye-bye.